first, we're going to talk about polygons. Polygons are closed figures. And when I say a closed plane figure, that means that it's a flat surface. It exists in one single plane. So it's a closed figure that's formed by 3 or more straight lines. And they're only going to intersect at their endpoints. And so there's no curved lines on a polygon. It's all just straight line segments. There's no sort of figure 8 or hourglass shape. So something like this here, like a bow tie, is not considered a polygon because it intersects at someplace other than the endpoint. Okay, but that's, again, if you see a closed figure with all straight segments, you're talking about a polygon. Hey, when you name a polygon, you're going to name it using consecutive vertices. Okay? A vertex is the intersection of 2 sides. So point A, B, C, D, and E in this first one, those are all vertices, is the plural. Okay? So vertex, vertices is the plural. But the vertex is just the endpoint where 2 sides meet. And you're going to name any polygon just with a string of letters that contain all of their vertices in any order. I started at A because you generally will see them in alphabetical order, but you could have started at E, and you could have actually gone the counterclockwise as well. So you could have also called that E, D, C, B, A. Any combination or order of those, as long as they go in consecutive order, will work as well. And so keeping in mind with vertices the endpoints of each side where they intersect. And endpoints or the vertices are either going to be consecutive or non-consecutive. So consecutive vertices means like if we start with A, the 2 possible vertices that are consecutive with A, one going clockwise would be E, and the other going counterclockwise would be B. Okay, so those are the consecutive, meaning that they're just the next one that you come across as you move along that figure. The non-consecutive vertices, again, if we start with A, then the vertices that would be non-consecutive to A would be the ones that aren't consecutive. So the only other 2 would be C and D. So those would be the 2 non-consecutive vertices regarding point A. Now each individual vertex will have its own set of consecutive and non-consecutive vertices. Okay, the side is pretty standard or straightforward. It's that segment itself, the segment that connects 2 endpoints. And again, those endpoints are called vertices. And so when you're looking at these, you also have consecutive and non-consecutive sides. So if you're looking at consecutive sides, and again, if we just start with AB here, the sides that are consecutive are the ones that can be formed from the endpoints of that given side. So the side that also shares point A is AE. And the side that also shares vertex B would be BC. So those would be your consecutive sides. And then the non-consecutive again, with regard to side AB, would be the ones that don't share any common vertices. So CD and DE would be those. Right, when you are naming polygons, notice that the way that this is kind of phrased here is n-gon, where n represents the number of sides. Okay, but most of these classifications are things that you're probably familiar with or you've heard. You do need to know them. I will use the words that represent the number of sides for each one, but a triangle, pretty common, has 3 sides. Quadrilateral has 4 sides. Sometimes you'll see a quadrilateral and you want to classify it as something more specific. But if you look at this, let me see if I can get a better version of it. All right, there we go. So if you see something like this, what do you guys kind of tend to think that that's called? Yeah, you probably think of it as a square. But when it's classified as a polygon, it's only based on the number of sides. So this is a quadrilateral. Even though it is also a square, and we'll talk about classifications of quadrilaterals later in the year. But when you see something like this and it asks you to classify it, it's simply a quadrilateral. Okay? Same with a rectangle, same with a parallelogram, same with the trapezoid. All of those would still just be considered quadrilaterals. Okay? 5 sides is a pentagon, 6 sides hexagon, 7 sides not used as much, but that's a heptagon. 8 sides octagon, 9 sides, again, not used quite as much, but that's a nonagon. 10 sides decagon. The other ones beyond that, I mean, there are some names for things, but beyond 10 sides, I'm just going to be using the number or the reference of whatever the number of sides is. So I would probably call it a 12gon instead of a dodecagon, even though it has a name. I would call 11gon, 58gon. Anything that has more than 10 sides is just the number of sides dash gon. Okay? So that's kind of the typical way that that will be referenced. Right, the last thing to kind of pay attention to or be aware of is that polygons fall into one of these 2 categories. And they're either classified as convex polygons or concave. Okay, and so the way that I always kind of think of this is I start with concave. Concave has what looks like a cave opening in it, right? It has this little opening, this indentation on it. And so that's the way that I can identify concave. But both of them have to do with all the diagonals that you can draw in the figure. Okay? And so here's the difference. In a convex polygon, no part of any diagonal falls in the exterior of the polygon. And I'll explain what that means here in just a second. Versus a concave polygon where some part of its diagonal, or of a diagonal, is going to fall in the exterior of that polygon. All right, so let me show you with an example. So a diagonal is just a segment that connects non-consecutive vertices. Okay? So when you look at So when you take this figure right here, so this figure has 5 sides, okay? We're dealing with a pentagon. And if we choose a vertex and connect all the segments that you can form to non-consecutive vertices, these are diagonals. Okay? If I go from another vertex and draw in all the diagonals that I can, connecting non-consecutive vertices, if I come up here, I have one already drawn, but I can draw the other one. And then when I look, both are drawn here, both are drawn here. So what I've done right here is I've drawn in all the possible diagonals for this polygon. Okay? Do any part of these diagonals fall outside the figure? No. So that's why this is convex. Okay? No part of any diagonal falls outside that figure. Now, when I do that same thing to this this concave polygon down here, I'm just going to draw the one that I easily see falls outside the figure itself. And so right now, you know that that would be considered concave. Okay, so concave means some part of a diagonal falls outside, but you'll see a little cave opening or indentation. Convex means no part of any diagonal falls outside. All right, so you'll be asked some questions about that just use these terminology here to identify different things and to classify polygons and so on. I'm not going to go through examples of those, but if you do have questions when you're working, please feel free to ask. Okay, the rest of what you're going to see in this section is just some basic perimeter area formulas of common figures. Okay, so the first one we're going to look at is that of a triangle. And you should be familiar with this already, that the perimeter of a triangle is just the sum of its sides, A, B, and C. And the area of a triangle is the formula 1/2 base times height. Now, do keep in mind with a triangle that most of the time students see this, the bottom base or the bottom side as the base, and the corresponding height is always the perpendicular segment from that base. But you could have called this the base. Any side of a triangle can be the base. It just would need the height that corresponds to it. So this blue height, H2, would be the height. So with that in mind, I want you to just really quickly see if you can calculate the area of this triangle, please. When you're finding the area, the base and the height have to correspond, meaning the base or the height has to be the perpendicular segment from whatever base you're measuring from to the opposite vertex. So looking at this triangle, what is the base that we're going to use in our calculation?
6.
Yeah. So if you look base times height, the base that we're going to use is this measure 6 because it has a corresponding height of what?
15.
There you go. Your answer can be a calculation. So once again, I encourage you just to enter this. Not only does this save you some time, save you the opportunity to not make some calculation mistakes or to translate your answer over from the calculator incorrectly, it also shows that you understand the formula. 1/2 base 6 times height 15. And you can also do the full calculation, right? Half of 6 is 3. 3 times 15 is 45. You're going to see over here in that preview that the answer is 45, so either of those is acceptable. Okay. See if you can do the same thing with the next problem. This one is on a grid or on a coordinate plane. Okay. So see if you can use the information provided here to figure out what would be the base, the height, and therefore the area of that triangle. All right, so on this, we're still using our area formula, 1/2 base times height. And what's the base of this triangle? Yeah, you can just count this over, right? So from 3 to 7, we're going 1, 2, 3, 4 units over. And then the height, just count the height. So from this base to the opposite vertex, if you extend this out a little bit, you can count 1, 2, 3, 4, 5. So there's your measurements. Once again, you can enter your answer as a calculation. Okay, that would be an acceptable form. And if you're going to do the calculations, 1/2 of 4 is 2. 2 times 5 gives you what the preview will also show, which is a total area of 10. Now, area is calculated in square units. For a lot of these, we're not focused on the unit values. There will come a time, though, that units kind of play a role, or you have to identify them. So just know, area is a two-dimensional measurement, okay? And so the units are going to be in square units. All right, the next basic shape for area and perimeter that you need to be familiar with are rectangles. Okay, and so once again, the perimeter is just the sum of all the sides, but because a rectangle has opposite sides that are equal, you can shortcut that and say 2 times the length plus 2 times the width. You can also think of it as 2 times the sum of length plus width, and that would be another way to think about the perimeter. And then the area is just the product of that length and width. All right, so based on that, see if you can answer. I'll have you do all 3 of these because, again, they're just like really basic plugging in the given value. So see if you can answer these 3 questions here in the next couple minutes. So for the perimeter of a rectangle, okay, you can, if you want, you can just simply add up all the sides. So you could actually put here 29 plus 15 plus. Now opposite sides of a rectangle are equal, so you could say 29 again and 15 again. So you could just physically type that whole sum in, and that's fine. And you can also use this formula, and the formula says here that you take 2 times the length, which is 29, plus 2 times the width, which is 15. And so that would also be a way to express your answer. Whichever one you choose, you should see the preview will say 88. So again, enter a calculation or complete the calculation and enter the answer is fine. Okay, area formula is going to be the length, 29, times the width, 15. So once again, if you just enter that calculation, you're good. If you do the calculation and enter the actual value, either of those are acceptable answers. Okay. All right. The next question is a square. A square is also considered a rectangle, so the formulas for the rectangle would also work. However, more specifically, the length and the width are exactly the same, so you could simplify it and just say 4 times the length of that side. Okay, so if you know that this side length right here is 16, the perimeter is going to be 4 times that, which will equal 64. And the area is length times width. It's still the same formula as the rectangle, but because the length and width are the same thing, you can simplify that and say it's the side squared. And so if you enter 16 squared or 16 times 16, you'll get your calculated answer of 256. And once again, either the calculations or the calculated values are acceptable ways to enter your answer. All right, if you haven't answered this last question here, just take a quick second to try it. Okay? If you already answered, you can just wait patiently, but I do want to go through this because this is sort of a multi-step question. Okay? So make sure that you carefully answer this specific question that's asked, okay? And read through the problem carefully. Notice in this problem, it's asking you both, or it's involving both the perimeter and the area. Okay, and so what you're being told is the perimeter of a square is 64. So let's say I label what I have. So P equals 64. Well, what is the perimeter formula for a square? It is 4 times S. And so if we solve that equation for S, 4 goes into 6 once with 2 remaining. 4 goes into 24 6 times. So what this means is we're dealing with a square with a side length of 16. And now the problem did not ask us to find the side length. It asked us to find the area. And so what's the area formula? Area formula is 16 squared. And so your answer is either the calculation 16 squared, or you can do the full calculation out. And so you would enter your answer one of those 2 ways. So again, make sure that you're finding the entire answer when you're calculating something like that. All right, the final slide has the 2 slightly more challenging questions, still talking about perimeter and area, but this time it's going to be given a coordinate plane and plotting points. Okay, I want you to start with the one on the right first, the rectangle, okay, and see if you can plot it and then calculate the perimeter and the area for that, please. And so I'm going to plot the points. Negative 5, 5 is point A. Point B is 8, 5. So 8 on the X, 5 on the Y. Point C is 8, negative 2. And then point D is negative 5, negative 2. And what you should see here is that this forms a rectangle. Right, so here is the figure that we're looking to calculate measurements for. A rectangle is relatively simple. You can count the pieces. Okay, and so the perimeter is 2 times the length. Well, what is the total length here? From 5 to 8, or from negative 5 to 8 is, so here's 5, a distance from 0. This is 8, so a total of 13. So 2 times 13 plus, and here the width or the height is from 5 to negative 2, which is, again, if you think here, 2 up, 5 down, which is a total of 7. And so when you type in this as a calculation, you get 2 times 13, which is 26, plus 2 times 7, which is 14. That's going to give you the overall calculated value of 40. Okay, and again, you can enter your calculation or the calculated value. Area, we have the measurements right here of 13 and 7. And so if we just take the product of those, think about if you are doing this with calculation, 7 times 10 is 70, 7 times 3 is 21. You're building up to 13 there. So 70 plus 21 is 91. That's going to be the calculated value. All right, so rectangle is relatively easy to do here. Triangle is going to be a little more challenging. I want you to try to see if you can find the perimeter and area of a triangle. It's probably going to be easier for you to find the area, and that's okay, if that's all you can do. But see if you can figure out how would you calculate the perimeter as well. Okay? Start off by plotting the points. So negative 3, 6, point A, 8, negative 4, point B, and negative 3, negative 4, point C. So at this point in time, we're still just looking at right triangles here. So we can find our length and or our base and height, okay, for this triangle easily because we have this right triangle here. So calculating the area first, we find the base from negative 3 to 8. Again, we go 3 units this direction, 8 units here. What's that total length? 11. And then for our height here, we go from negative 4 to 6. So here we go up 4. Here we go down. We're 6 away. So that total height is 10. So there's our units, or our measurements for the base and height. So the area, make sure you put the 1/2. That's probably what will be forgotten the most often. But 1/2 the base, 11 times the height of 10. It doesn't matter which one you use as the base and which one you use as the height. Okay? Most students do use the bottom side as the base, but it doesn't have to be. Okay? But here the corresponding height to that base 11 was 10. And so this would be our calculation. If you were taking half of 10 is 5. 5 times 11 is 55. And so either of these would be acceptable answers. Just enter the calculation or the calculated value. All right. The perimeter is going to be a little more challenging, right? Because the perimeter is the sum of all 3 sides. We have 2 of them. We have 10 and we have 11. But we have this third side. You can't count the distance here from A to B. So what do we need to use to calculate it? That we did in a previous section. So here we just need the distance between 2 points. Do we have a formula for distance on a coordinate plane? Distance is equal to the square root of the difference of their coordinates, right? So if we were to think of the coordinates here, negative 3, 6, and B, 8, negative 4. So we could plug these in and take the difference of our x's. So if I take negative 3 minus 8 squared plus the difference of our y's, 6 minus a negative 4 squared, I can enter that if I wanted to specifically as this final calculation. Okay, I could take negative 11 squared plus minus a minus. Subtracting is equivalent to adding the opposite. So plus 4 is 10 squared. And so if I entered this as my calculation, I'm good. Okay, if I worked through and solved for this, negative 11 squared is 121. 10 squared is 100. And so if I continued this, I would get my 221. And so I could have entered that. I could have found the decimal equivalent and plugged that in as well. Right? And my answer in decimal form winds up being 35.87. So I can enter my answer as this full calculation or as this approximate answer. Okay, now, there's another way that you could have done this that we haven't specifically talked about yet, but you might have done because you are probably familiar If you have two sides of a right triangle, what can you use to find the third side? Do you remember what that's called? A squared plus b squared equals c squared, right? And this is what the distance formula is based off anyway. So if you said A, B, and C here, you could have solved using Pythagorean theorem, where A is 11, B is 10, and C is this distance right here, right? And so if we extract the square root, notice we get the exact same thing as up here. Square root of 121 plus 100, same step as this. Root 221, same step as this. So all of this is what you could write for your third side, your hypotenuse or side C. Okay? So any of those wind up working, but what we've done in the class is the distance formula, and so that's what I would recommend using.